Hi, Enthusiastic Steve here. I've been busy the last few days actually designing and building and testing a multi-band HF antenna. Okay, in this video I'll show you how to build and use this multi-band HF antenna using an unknown and a random length of wire. When I say random, it is random, but I will give you the lengths that work the best with this unknown. It's a 9-to-1 unknown, and I will explain what an unknown does for those who don't know a little bit later in the video. I will then show you a table and some charts of the various lengths of wire and what type of VSWR results you get across the bands. This is not a magic antenna. There's a little bit of physics involved with this, really, how it actually works, and I'll explain what we're trying to achieve. It will work from 40 meters up to 10 meters. It will work on 6, it will work on 80, but not as efficiently as those other bands. So let's have a look at what we got, see what we need to make one. We'll make it, put it together, put it on a pole. We'll do some test transmissions, we'll try a little bit of whisper, and just see how these things perform. By the end of this video, you will be able to go out with a piece of some basic tools, some basic wire, an unknown, either homemade or otherwise, and just fit it all together and get on air and transmit around the world. So let's look at the design and see what's required to actually make a multi-band antenna. You need just 4 main components: a wire of a certain length, a unknown of 9-to-1 ratio, some coax and a choke. Let's start with the wire. Now, the wire can be of various lengths, and we'll look at what's best later. What you need to ensure is that any length of wire you use is not resonant. It's not a quarter wave or multiple on any of the frequencies that you're working. It must fall in between. The reason for this is you're not trying to match a direct 50 ohm load. You're looking to try and achieve a 450 ohm load and then use a 9-to-1 unknown to bring that impedance down. We will come back to the unknown in a minute, but the length of coax you require between the unknown and a choke, I use about 15 feet. Now, the choke itself, you can buy a 1-to-1 choke, or you can actually make one up using the coax itself and twist it, or maybe put a magnetic ferrite ring around it. This just restricts and stops any RF coming back down into the radio and into the shack or into your car. This is the choke I made. It's not the prettiest of things, needs a little bit more tape and a little bit more cleaning up, but it's just 6 or 7 coils of the coax, approximately 1.5 to 2 inches in diameter, and a magnetic ferrite bead attached to the coax as well. This stops any RF coming back down past this point. So now let's speak about an unknown. A lot of you may already know what an unknown is, but let me explain it for those who don't. With a little bit of patience, you can actually build your own unknown. But what I've done is I've bought one from a manufacturer. This is an LGG version. There are other manufacturers that make these. So what is it and what does it do? Firstly, don't get this confused with a balun. Unknown simply stands for unbalanced to unbalanced, whereas balun stands for balanced to unbalanced. In this antenna, we've got a coax going into the box, the transformer, and coming out as a wire, unbalanced to unbalanced. Inside the box, we have a transformer, and this transformer's purpose is to step down the high impedance from the antenna to something usable that the radio can accept. In this instance, we're converting approximately 450 ohms resistance from the wire down to 50 ohms. A factor of 9-to-1, hence it's called a 9-to-1 unknown. So what do you need to do to build, put together and put this antenna on air? Well, it couldn't be simpler really. A length of a wire, a bit of tape, something to cut the wire with, your 9-to-1 unknown, and a tape measure. Measure the wire to the correct length. Now, we'll talk about this in a minute. Attach it to the post on the top of the transformer and attach a length of coax to the base. The only modification I did to the unknown was to use a bolt through some Velcro straps to make it easier to attach to a fiberglass pole. like this. As I mentioned earlier, the choke is very important. There was just the coax with the windings on it and the magnetic bead. Now, from a wire perspective, I use a braided wire, because it's more flexible. You can tin it, but the only thing you need to check is to make sure that the thickness of the wire will actually go through the hole on the actual unun. Here's the unun, and this is what I mean, the attachment post on here. If you unscrew the terminal block, you'll see the tiny little hole there, and as long as the wire can fit through there, you're all good to go. It just screws down and fastens. You can tin the wire and give it a bit more longevity. The correct wire length is essential if you want to use this as a multi-band antenna, especially if you don't want to use a tuner. So what I've done is I spent about 2 days in and out of the garden playing around with different lengths of wire, making up a table to see how they perform over different bands. From this I've managed to produce a table and some charts to show you how they perform. Now you can make this antenna with a much longer wire, especially if you're going to put it around a garden. But I've done this design purely really to be used on a fiberglass pole, a 7 metre or 10 metre pole. Here is a table showing the results I got from using a 23, 24, 24 foot 6 and a 29 foot long wire on 40, 20, 17, 15, 12, 11 and 10 metre bands. Now as you can see, I'm getting some very good VSWR matches there. I wouldn't need a tuner at all to actually use those wires on any of those bands, though a tuner would actually just tweak down the 2.1s and the 2.4s. Now the mistake a lot of people make is to concentrate purely on getting a good VSWR. Yes, it is important, but what we've got to remember is the radiation pattern from these antennas. Once you get up to nearly a full wave equivalent, you're going to have some problems. So you need to make sure these antennas really are nearly 3/4 wave or 5/8 or half wave or quarter wave. And that way they work more efficiently. So the longer antennas are nearer a quarter wave on 40 meters, and they also work up to 10. At 10 meters, they're approximately 3/4 to 7/8 wave antennas, so do project their RF quite low angle radiation. But don't forget to give that 450 ohms we're looking for. They cannot be resonant on their natural length. The transformer then does its job, converts it down to as close to 50 ohms as it can, and it's a multi-band antenna ready to use. Right, for those who don't like using or reading tables, let me present this information in a graphic form. This graphic shows exactly the same information from the table. You might be able to read this a little bit clearer, and it shows the peaks and the troughs of the VSWR readings. It's the 17 metre and 20 metre bands which are a little bit higher, but still generally under 2.4. Which wire length you decide to use yourself is up to you really. If you're going to put it on a pole, if you've got a 7 metre pole, that will dictate a shorter one. If you've got a 10 metre pole, I'll go for a longer one. You also know I added a 30 foot length of wire to this graphic, just so you could get a comparison. And I actually started off using one of these on my pole myself. So let's test this design. I'll put the unun onto the base of the fiberglass pole. It's 10 meters long. I ran the wire down its length, and I used a fairly non-sticky tape to actually secure it. Be careful of using tape on a fiberglass pole because it can unlaminate it. The 10 metre poles then stood on a small tripod weighted down by concrete blocks and connected the coax and ready to go. The testing took place in the middle of the day, so I thought I'd try a little bit of Whisper, the old propagation tool. 5 watts across the 40 metre band up to 10 metre band, just to see what the propagation was like and how the antenna was performing. After seeing the initial results, there was only one word I could find to describe this antenna: awesome. This antenna, don't forget, is only 12 to 18 inches off the ground. 5 watts of power. And look where the signal's going. These are the reports I got back from Whisper. Alaska, west coast of America, South America, Antarctica. There's one actually by Chile. Now, if you look closely, it's in the sea, because that's a supply vessel for the Antarctic base down there. It's also performing fairly well out to the east as well, getting across Russia, down to Taiwan, down to Australia, the eastern side, and even into Tasmania. These reports only came back after just a couple of hours of running Whisper, mid-late afternoon into the early evening. Mexico 6, Whiskey Victor Victor.
Mexico 6, Whiskey Victor Victor, hello, you are 57 QS Baker, roger.
Roger there, Ivan. The operator name here is Steve, Sierra Tango Echo Victor Echo. Your lovely 5x9 plus 5 dB here on the South Coast UK. Just using a homemade vertical antenna. Mike Sits Whiskey Victor Victor. Afternoon, Chris. This is Mike Sits Whiskey Victor Victor. Your 5x9 South Coast UK. Running just 10 watts for a vertical antenna. Back to you, Foxtrot Yankee 5 Kilo Echo.
Roger for the 10 watts and precise my report for you. Updated 5.7 done for the real report now. Thank you for the 5.9 report. 7.3 and good yet.
7.3's Chris. All the best. Italy 8 Whiskey Romeo Tango Charlie. This is Mexico 6 Whiskey Victor Victor.
Mexico 6 Whiskey Victor Victor is a 5.9.
You're also 5x9 here on the South Coast UK. Operator name is Steve. Nice to make contact. 73s and good luck with the station.
Victor Victor 5.9 plus 50 on the Atlantic coast of Spain, La Coruña, QSL.
Yeah, QSL. The operator name is Steve. You're 5x9 plus 20 on the South Coast UK.
Roger.
Those contacts were made using the 23, 30 foot and 29 foot wire lengths. They all work very well. So there you go. That's the multi-band HF antenna. It's quite awesome, really, to think one little bit of wire can work on all those bands without a tuner. Yes, you can use a tuner to tweak down that last little bit of VSWR, but you don't need one. So that's the beauty of this antenna. For those going out portable, most radios today will have a built-in tuner, but if you don't have a built-in tuner, you don't need one. It's as simple as that. Fiberglass pole, wire, some coax, and you're good to go on 40 meters up to 10 meters. As you can see by the Whisper, that was on 5 watts. Got very well, almost right around the globe there. I think Hawaii was, and probably a little bit of Africa I didn't get into, and I was only transmitting for a few hours the other afternoon and evening. If I left it on all night, I'd probably made some longer contacts. It also receives fairly well as well, considering it's a vertical antenna and I had it in an urban environment. It was receiving fairly well also. I got down to French Guiana on 10 meters and I've made some contacts into Europe. So very happy indeed, considering the antenna is in my back garden, which is lower than my property. So the antenna, 30 foot high, was only just sticking above my rooftop. So it was actually enclosed in. So works really well. Hopefully this has encouraged you to go out and build your own or give it a go. It's a decent antenna, it works. And playing around with those wires, if you've only got a small pole, use a 23 foot, 21 foot or 23 foot wire. If you've got a longer pole, use the 29 or 30 foot wire. They all work. They work a little bit better in certain areas, but they all work. And that's the beauty about it. All folds down, slip in your rucksack, go up a hill. Have fun. Enjoy the hobby. Thanks for watching. This is Enthusiastic Steve saying 73s. Please press that subscribe button if you've not done so before. And I look forward to playing some more videos to you shortly. Thank you for your comments. I'm always happy to respond to them. And see you all soon. This has been Enthusiastic Steve. Oh, one last thing. Counterpoises. Do you need one? Well, actually, you don't. This antenna will work without a counterpoise or a ground. There is a stud or connector on the top of the Unknown for a ground wire if you require one. But the coax underneath, the 15-16 foot, will actually act as part of a counterpoise. But if you add a counterpoise, it will help your signal and it will lower the RF radiation pattern. And it will help you in attaining a low VSWR. But as I've shown, it does work very well without one.